You trust reality without thinking about it. You wake up, touch the floor, feel its solidity, and move through your day assuming everything around you is exactly what it appears to be. Objects stay where they are. Causes lead to effects. The world feels stable, predictable, and real. That certainty is so natural, you rarely question it. But what if that certainty is misplaced? The chair you're sitting on feels solid. Your phone feels like a fixed, well-defined object. Even the air seems empty and calm. Everything gives the impression of being continuous and stable. But this is only what your senses allow you to perceive. Your brain is simplifying reality. It takes an incredibly complex world and compresses it into something manageable. It smooths out the details, removes the uncertainty, and presents you with a version of reality that feels consistent. Not because it is, but because it has to be. Now imagine zooming in closer and closer. At first, nothing changes, but eventually the familiar world begins to dissolve. Objects that once seemed solid start to break apart into smaller pieces. And even deeper, something even stranger appears. Something that doesn't behave like solid objects at all, because at that level, the rules change completely. The stability you rely on starts to disappear. Particles don't sit neatly in one place. They don't follow clear paths. They don't behave like tiny versions of the objects you see every day. Instead, they exist in ways that are difficult to picture, let alone understand. And yet, this hidden world is not separate from your reality. It is your reality. Everything you see, touch, and experience is built on top of it. The solid chair, the steady ground, the predictable motion, all of it emerges from something far less stable and far more mysterious than you ever imagined. So why don't you notice it? Because your senses were never designed to see that level of detail. They evolved to help you survive, not to reveal the true nature of the universe. Your brain filters out the strange behavior and replaces it with something simple and reliable. But that simplicity comes at a cost. It hides the truth. And that truth is unsettling, because if the foundation of reality doesn't behave the way you expect, then what you experience is not the full picture. It's a simplified version, a useful illusion. Think about that for a moment. Everything you consider real is based on a filtered interpretation of something much deeper, something that doesn't follow the rules you trust, something that challenges the very idea of certainty. This is where the story begins to shift, because once you accept that reality might not be what it seems, a new question emerges: what is actually happening beneath the surface? And the answer leads you into a world so strange that even the greatest physicists struggled to fully accept it, a world where reality doesn't behave like reality at all. The hidden world beneath everything. Now that the surface of reality has started to crack, you're ready to look beneath it, not just conceptually, but physically, because everything you experience, every object, every sensation is built from something much smaller, something you never directly see: atoms. You've heard the word before. But the moment you go deeper, that simplicity disappears, because atoms are not small solid balls, like miniature versions of the objects around you. They are mostly empty space. At the center, there's a nucleus. Around it, electrons don't orbit like planets. They don't follow clear paths. In fact, they don't have precise locations at all. Instead, they exist as probabilities, clouds of possibility, rather than fixed points in space. That alone is strange. But it gets stranger. If you try to pin down exactly where an electron is, you run into a problem. The more precisely you try to measure its position, the less certain you become about its motion. And if you try to measure its motion precisely, its position becomes uncertain. This is not a limitation of your tools. It's built into reality. At this level, things do not have definite properties until they are measured. A particle is not simply here or there. It exists in a spread of possibilities, only taking on a clear state when something interacts with it. Instead of objects with fixed positions and predictable paths, you get something more like a wave of possibilities. A particle can exist in multiple potential states at once, not because it's hidden, but because that's how it fundamentally exists. Only when you interact with it does one outcome appear. This forces you to rethink something basic. What does it mean for something to exist if it doesn't have a definite state? Because in your everyday experience, existence is tied to certainty. Something is either there or it isn't. It has a position, a form, a state. But in the quantum world, those ideas begin to blur. Particles don't behave like tiny objects. They behave like something in between, part object, part wave, part probability. And this isn't just a theoretical curiosity. This is the foundation of everything. The solid world you experience is built from this uncertain, shifting reality. Every atom in your body, every object you touch, is made from particles that don't behave in solid, predictable ways at all. So the stability you feel is not fundamental. It emerges from something far less stable. And that raises a deeper, more unsettling question. If reality at its core is uncertain, then what determines the outcome you actually see? Because somehow, from all those possibilities, only one becomes real, and understanding how that happens leads to one of the strangest discoveries ever made, a discovery that suggests reality itself may depend on something you never expected. The strangest discovery: reality depends on observation at this point. Reality already feels unstable. Particles don't have fixed positions. They exist as probabilities, only becoming definite when something interacts with them. But there is one discovery that takes this idea further, so far that it begins to challenge what you even mean by reality. It starts with a simple question. What happens when you try to observe a particle? You might assume nothing unusual. You look at something and you learn what it's doing. That's how observation works in everyday life. But at the quantum level, observation does more than reveal reality. It appears to shape it. To understand this, imagine a particle moving toward a barrier with two narrow openings. If it were a tiny object, you would expect it to pass through one opening or the other. Simple, predictable. But when physicists perform this experiment, something unexpected happens. The particle behaves like a wave. Instead of choosing one path, it spreads out, passing through both openings at once. The result is a pattern that can only be explained if the particle exists in multiple possibilities simultaneously. It's not just going left or right, it's doing both, until something changes. Now comes the strange part. If you try to observe which opening the particle goes through, the behavior changes instantly. The wave-like pattern disappears. The particle now behaves like a solid object, choosing one path. Just by observing it, you force a decision. This is not because you disturbed it in a normal way. Even when the measurement is as gentle as possible, the effect remains. The act of observation itself seems to collapse all possibilities into a single outcome. This is often called the collapse of the wave. Before observation, the particle exists as a range of possibilities. After observation, only one remains. So what was it before you looked? Was it really in multiple states at once? Or was it always in one state, just hidden from you? Physicists have debated this for decades, and there is still no single answer that fully satisfies everyone. But the experiments are clear. Observation changes the result. This creates a deeply uncomfortable idea because it suggests that reality is not fully defined until it is observed. Think about that carefully. In your everyday world, things exist whether you look at them or not. A tree doesn't vanish when you turn away. A planet doesn't wait for someone to measure it before it decides where it is. Reality feels independent, stable, and objective. But at the quantum level, that independence begins to fade. Instead of a fixed reality, you get a set of possibilities waiting to become real. And the moment of observation is what selects one of them. This doesn't mean your mind is creating reality in a simple sense. It's not about conscious thought magically changing the universe. It's about interaction, measurement. The moment when a system becomes linked with something else, forcing a definite outcome. Still, the implication remains. Reality is not fully settled until something interacts with it. And that breaks one of your deepest assumptions, that the world exists in a definite state, independent of observation. Because here, certainty is not a starting point, it's an outcome. And that leads to an even deeper problem. If reality is built on probabilities and observation selects outcomes, then how predictable is anything? Because once you remove certainty from the foundation, something else has to take its place. And what replaces it is not what you expect. The collapse of certainty. Nothing is truly determined. Once you accept that observation selects outcomes, another question immediately follows. If particles exist as possibilities until measured, then what decides which possibility becomes real? Is there a hidden rule behind the scenes? Some deeper layer quietly determining the result? You would expect there to be. After all, everything in your daily life feels predictable. If you drop something, it falls. If you push an object, it moves, cause leads to effect in a clear, reliable way. That sense of order makes the world feel stable, almost mechanical. But at the quantum level, that predictability disappears. Instead of certainty, physics gives you probabilities. You can calculate the chances of where a particle might appear. You can predict patterns over many repeated experiments. But for a single event, for one specific outcome, you cannot say exactly what will happen. Not because you lack information, but because that exact outcome is not determined in advance. This is one of the hardest ideas to accept, because it means that at the most fundamental level, the universe is not fully predictable. There is no hidden script guaranteeing that a particle will choose one path over another. There is only a range of possibilities, each with its own probability. And when the moment of measurement arrives, one of those possibilities becomes real. Why that one? Physics does not give a deeper reason. It simply gives the probabilities. Even the greatest minds struggled with this. Albert Einstein famously resisted the idea, believing that reality must have some underlying certainty. He argued that something was missing, that the theory was incomplete. But despite decades of effort, no hidden mechanism has ever been found that restores full determinism. Experiments continue to confirm the same conclusion. Uncertainty is not a flaw in the theory. It is a feature of reality. This changes how you think about cause and effect. Instead of a strict chain where one event inevitably leads to another, you get a branching structure. Multiple possible outcomes exist, and only one is realized. The future is not fixed. It is open-shaped by probabilities rather than certainties. And yet, your everyday experience still feels predictable. That's because when you scale up from tiny particles to large objects, these probabilities average out. The randomness becomes invisible. The strange behavior at the quantum level blends into the stable world you recognize. It creates the illusion of certainty. But underneath that illusion, the uncertainty remains. Every event, no matter how ordinary it seems, is built on a foundation where multiple outcomes were possible. You just never see the alternatives. You only experience the one that happened. This leads to a subtle but profound shift. Reality is no longer a single predetermined story. It is the result of countless possibilities, narrowing into one path, moment by moment. And that raises a deeper question. If nothing is truly determined at the most basic level, then what does that say about the nature of reality itself? Because once certainty collapses, the world is no longer what you thought it was. And the final insight takes that realization even further. The deeper truth, reality is not what you think at this point. The picture is impossible to ignore. The solid, predictable world you trusted has been stripped down to something far less certain. Objects are not truly solid. Particles do not have definite states until measured. Everything you experience rests on a foundation of probabilities and interactions. So what is reality, then? Not the stable structure you imagined, not a fixed stage where events simply unfold. Instead, something far more dynamic, something that only takes shape through interaction. Reality is not just there, waiting to be observed. It is constantly forming, moment by moment, as possibilities collapse into outcomes. That changes everything, because it means what you see is not the full story. It is the result of countless processes happening beneath your awareness, processes that do not follow the rules your intuition expects. What feels solid is mostly empty space. What feels certain is built on uncertainty. What feels independent may depend on interaction. And yet, your experience remains consistent. You don't see objects flicker between possibilities. You don't feel randomness shaping your daily life. That's because, at your scale, everything blends together. The strange behavior averages out, creating the illusion of a stable, objective world. But it is still an illusion, not a false reality, but a simplified one, a version of reality that hides its deeper nature. This leads to a profound shift in perspective. Instead of thinking of reality as something fixed and independent, you begin to see it as something relational, something that depends on connections, interactions, and measurements. The idea of an absolute observer-independent world becomes harder to define. And this is where things become truly unsettling. Because if reality depends on interaction, then what exists when there is no interaction? Does the universe have a definite state when nothing is measuring it? Or does it remain a vast field of possibilities, waiting to take form? There is no simple answer. Different interpretations of quantum physics offer different perspectives. Some suggest that all possibilities exist simultaneously. Others propose that outcomes are selected in ways we do not yet fully understand. But none of them restore the simple, intuitive picture you started with. That picture is gone. In its place is something deeper, stranger, and far more difficult to grasp. Reality is not a collection of solid objects moving through time. It is a constantly unfolding process, shaped by probability, interaction, and observation. And once you see that, you can't fully go back. Because the next time you look at something, a table, a wall, your own hand, you'll know that what you're seeing is not the full truth. It's a surface, a stable appearance built on top of something far more complex, something that doesn't behave the way it seems. And that is the real shock. Not that reality is strange, but that it was never what you thought it was in the first place.